All right, why don't we get started in the interest of time, and so we can, give our panelists ample time to have a fruitful discussion today. Thanks everyone for joining today. Welcome to the second virtual event in the Global Adaptation and Resilience Investment Working Group's virtual speaker series, where we seek to bring together experts and practitioners from across the world to share their knowledge and expertise on key aspects around financing, investing in climate adaptation and resilience. My name is Serena Shi. I'm a vice president at the Lightsmith Group. We are an investment firm focused on investing in and scaling growth stage companies with the tools and technologies we think will be necessary to help manage, mitigate, and address the increasing impacts from climate change. Lightsmith also chairs the GARI working group, which is hosting today's event, and thus my representation in hosting today's discussion. For those not familiar with GARI, we are a private sector, private investor-led nonprofit organization. We were established in 2016 at the Paris COP21 in partnership with the UN Secretary General's A2R Climate Resilience Initiative. And our goal is to provide a forum for engaging stakeholders across the public and private sectors to discuss how to catalyze financing for much needed financing for climate adaptation and resilience. So since 2016, we've convened over 50 in-person and remote meetings across New York, Washington, D.C., San Francisco, and London, bringing together over 400 private sector investors and other stakeholders across pension funds, endowments and foundations, asset managers, banks, startups, think tanks, advisory firms, and development finance institutions, among other types of stakeholders, to discuss how we can scale financing for adaptation. And so our organization is focused on education, on expanding our stakeholder reach, and driving innovation in adaptation finance. And that's the goal of today's event, which we hope will accomplish all of those things. So we want to thank you for joining, and also really appreciate the contributions of all of our panelists today, and also want to quickly thank the Kresge Foundation for its generous support of GARI's work. So I'll quickly just give some background on Andrew Isle, who is moderating today's panel discussion. Andrew is a climate risk and resilience investment consultant, currently serving as the head of climate risk for North America with Tata Consultancy Services, a global IT solutions and advisory firm. He's a climate policy and market specialist with experience spanning diplomacy, development finance, and consulting. Andrew supports engagements with financial institutions to address climate risk-related challenges and opportunities, and has worked on issues related to resilience finance since 2016. Andrew has been generously involved with GARI since 2018 and joined forces with us earlier this year to help launch this virtual speaker series. This is the fourth speaker series event that he has worked with GARI to arrange. A quick reminder to all of today's participants that the event will be recorded, and the recording will be shared with participants after at some point later this week. And I guess, Andrew, I'll now pass it on to you to get the conversation kicked off.
All right. Well, thank you so much, Serena, for that kind introduction, and for jumping in for Lori here. Very excited to be back with GARI, and we have indeed been doing these for a couple of years now. So this is our second this year, but I think it's actually our fifth. I think I've lost count exactly how many we've done, but always exciting to speak with our audience of resilience investors and those around the adaptation and resilience community. And I'm particularly excited for the topic of today's seminar, or webinar rather, climate risk and scenario analysis, because scenario analysis is a topic that's been ripening for some time, but I think it's still relatively early days in our community's collective understanding of how scenario analysis can be used in the context of climate change and physical risk specifically. So I'm really excited that we have a terrific panel of very experienced experts, both theorists and practitioners, who can help walk us through what some of these scenario analysis approaches are and what their utility is in this space. I will start with a few brief remarks, as well as a couple of slides to set the scene, but I'm very eager to try to keep those as brief as possible so that we can dive into the remarks of our panelists and really get into a good discussion. So by way of background, let me make a few quick remarks to set the scene, and then I'll introduce our panelists. Since the Task Force on Climate-Related Financial Disclosures, or the TCFD, released its landmark recommendations in 2017, scenario analysis has been enshrined as a key element of climate strategy and risk management. However, scenario analysis and scenario planning remain among the least understood aspects of the TCFD recommendations, as well as the least implemented among supporters of the TCFD, according to the latest TCFD progress update published in the fall of 2022. Moreover, the TCFD's top-line guidance on climate scenarios focuses on financial impacts in a 2-degree or lower scenario, i.e. focus on the transition risk impacts more than the physical risk impacts. To some degree, TCFD redressed this gap with a publication released shortly thereafter, the use of scenario analysis in the disclosure of climate-related risks and opportunities. However, as the guidance noted at that time, many global climate models still have difficulties in projecting accurately extreme weather events at the local level, such as floods, precipitation patterns, and droughts, a challenge that has persisted to this day. Many recent extreme weather events driven significantly by climate change, including the 2020 Australian bushfires, 2021 Texas polar vortex, unprecedented flooding from hurricanes Harvey in 2017 and Ida in 2021, and recent wildfire seasons, droughts, heat waves, etc., have not been widely anticipated, at least to the degree one would hope, by risk managers and government officials, and sometimes scientists as well. These events are but a foretaste of the widespread, potentially devastating impacts of acute physical hazards in the near to middle term. A risk identified in the 2023 World Economic Forum, the failure of climate change adaptation, the WEF Global Risk Survey, as the second most severe global risk on a 10-year time frame, behind only failure to mitigate climate change. At the same time, a number of groups have been working to develop better physical risk assessment tools, such as the Coalition for Climate Resilient Investment, CCRI, and its PCRAM tool, emphasizing the need for credible methodologies and respective analytics to be developed and tested by practitioners and be integrated into physical climate risk tests in cash flow and modeling practices. Scenario analysis to capture extreme and nonlinear outcomes is one such methodology. In this context, better tools are needed to address rising uncertainty and severity of acute physical climate impacts. In other words, adaptation planning and investment designed to manage near and middle term as well as long-term climate threats. Climate scenario analysis and planning can substantially address this gap. What is climate scenario analysis done right, and how do we adopt it? How can we inform and lead to increased and improved resilient investment, particularly by private investors, asset managers, and corporate executives? This event will unpack and examine these questions. So let me briefly introduce our panelists here, and then we'll give a couple of housekeeping notes and background, and then dive right in. So I'm joined today by 3 esteemed panelists: Georgios Hadzalakos, the leading climate modeler for a major UK-based asset manager; Peter Raymond, founder and managing partner of Claim8; and Brian Geller, senior sustainability manager for the Durst organization. And we'll give fuller bios for them in a moment. The format that we'll use is, after my introductory slides, I will turn the floor to each of our 3 panelists for introductory remarks and slides as they see fit. That will take us through the first half hour or so. And then we will have a facilitated conversation on this topic, after which we'll open up the floor for comments and questions from the audience, which we will try to address at the tail end of the event. So please do drop any questions you have into the chat feature so that we can address them at the end of our event. I should also note that we're recording today's event, and we'll make a recording available shortly thereafter. And we also would like, before we dive into the panelist remarks, to do a very brief audience survey with 2 questions, which hopefully will pop up on your screen. There we go. Thank you. First, what is your experience with climate risk assessment? And second of all, what is your experience with scenario analysis? And hopefully this will help give our panelists a bit of a sense of the audience and the degree of detail we can dive into. So please do fill those in if you have the opportunity, and we'll close that survey in just a moment. So let me share my screen here and we will dive right in. Okay, so a few brief notes on climate scenarios. And I'll try to keep this brief and to the point here. First of all, what are scenarios? Scenarios are narratives or stories about the future and are useful in decision support. And this applies to many different disciplines, not just climate change. They can be used for conflict, for healthcare, for the financial sector, and indeed they are used widely across a good number of disciplines. In the climate change context, scenarios can focus on any number of different elements, including greenhouse gas emissions, market behavior, activities of individual agents or participants in markets or society, behaviors, industry, GDP, or any combination of those. Additionally, it's worth noting that data-driven scenarios use models to influence and develop a base for narratives. And narratives themselves are what set the parameters and determine the variables for different scenarios that make them distinct. Scenarios are used for critical decision support and for risk management, as well as for finding new opportunities. One definition of scenario analysis that I think is particularly helpful is that from the US Army Corps of Engineers, which emphasizes that scenarios are divergent stories about the future. They describe events which could happen, which might happen, and they're designed to take an outside-in focus, beginning with external forces and ending with internal actions that the organization that is conducting the scenario might take to prepare for and cope with the eventualities depicted. So it's very important to note that scenarios are looking at external forces, but are fundamentally about decision making for a particular entity or organization. And they tend to be focused on the issues that are most relevant to the mission. There are many different kinds of scenarios, as we just mentioned. And so the climate scenario methodologies, in many respects, draw on the history of scenarios from other domains, such as areas with which a general audience may be familiar, including projections of COVID-19 infection rates, which many of us were glued to in 2020 and 2021, GDP growth scenarios used very widely amongst central bankers and in the financial sector, and real estate asset pricing. Some of the advantages of scenario analysis and scenario planning more broadly are as follows. Scenarios help to challenge assumptions or unpack assumptions about what we may believe will happen or be the state of the world in the future. They help build integrative mental models about the future that embrace uncertainty, which is fundamentally what is being examined, is the uncertainty around different aspects of our future. They do not require consensus, and they really are facilitating an exploration activity. And they build strategic flexibility and flexibility around timing as well. As I mentioned in my introductory remarks, climate change and climate-driven threats are amongst the most highly ranked concerns of decision makers as identified by the WEF Global Risk Survey. And that is one of the reasons for which we are applying scenario analysis to this domain, because there's widespread recognition that climate represents a very serious risk at the global scale. Climate scenarios can adhere to one of a number of different types. There are financial stress tests that are often conducted by central banks and financial regulators of financial institutions. There are risk management exercises that are conducted by risk managers with the goal of improving operational and financial risk management and improving organizational readiness and resilience. And there's a more general role for strategic planning that manages uncertainties, not necessarily risk per se, but also looking at opportunities and trying to understand the state of the world as it might impact a particular organization and help inform its strategic planning. I'm not going to go too far into the details of different climate scenarios, but I do want to emphasize that many scenarios, as they're conducted today, are built around emissions pathways. And what that means is emissions pathways are projections of how society at the global scale will produce greenhouse gas emissions according to policy, according to technology, according to social shifts, and what that means in terms of the amount of warming the world will experience and then the knock-on effects. And so many scenarios are based around that, and I believe Georges can walk us through that a bit further. And so that's one bit of context setting that we won't delve into with great detail here, but is central to how many climate scenarios are conducted and constructed today. These tend to be based on a series of models using integrated assessment models to go from assumptions about society and the economy to emissions, and then Earth systems models and climate impact models, as well as natural catastrophe models, to get from a degree of emissions to an amount of warming and to particular climate behaviors. And then global macroeconomic models are used to extrapolate what sort of impacts on the economy are we likely to see from those changes to climate and to extreme weather. A few notes on narratives. Narratives are a key baseline framework for how a scenario is constructed. And narratives have a few important characteristics as they serve the scenario process. They should be relevant, plausible, illuminating, provocative, and actionable. And there are important steps towards planning the development of the scenario such that its results can be understood in context and then fed back into the decision-making process. A couple very brief notes on the policy space before I hand the floor to our speakers. As I mentioned, scenario analysis has been embedded in the TCFD framework since 2017, and so it is increasingly something that's been adopted by regulators and financial oversight bodies as a requirement. And so while it is a good risk management practice, it also is increasingly a requirement. And so many organizations are now grappling with these requirements as they are put in place by regulators. Amongst the stress tests and scenario analysis that have been most prominent are the Bank of England, the European Central Bank, and the US Federal Reserve. And I apologize for going through this so quickly, but we can revert to these slides if we need to for the purpose of our discussion later on. It's also worth noting that this is a field that's quite young, and there's been some recognition that the existing methods may not fully capture all of the risk exposures and vulnerabilities that many of society's actors, financial institutions, et cetera, actually face. This is something that financial oversight bodies and central banks have themselves recognized, and something that is an important piece of context for this discussion. And so, in summary, scenario analysis has been embraced by policymakers and industry as a critical tool for managing and disclosing climate change-related risks and opportunities. It's a valuable approach for managing uncertainty around possible disruptive and extreme climate events. It's a young field that's rapidly evolving and is facing some challenges and limitations related to methodology, data availability, uncertainty, and limited experience amongst practitioners. But thoughtful and creative construction of scenarios, including around narratives, can better prepare market actors for resilience. So I am going to, with that, turn the floor over to Georges. First, Georges' introduction. Georges Hadzalakos leads the climate modeling, data, and disclosure work stream within M&G, leading asset manager within their climate team. His work supports related climate reporting and portfolio decarbonization efforts. Prior to joining M&G, Georges led a specialized team in the Bank of England working on climate stress testing and assessing banks and insurers' alignment to regulatory climate objectives. Before that, Georges worked for Willis Towers Watson, WTW, where he led the climate and natural catastrophe risk modeling for reinsurance transactions. Georges has 20 years of industry experience on financial risk assessment from climate and environmental risks, spanning the insurance, regulation, government, and engineering sectors. He's an Imperial College graduate and as chartered civil engineer, has worked in-house with consultancies and at the regulator, both in the UK and internationally. So Georgios, delighted to have you. Thank you so much for joining us today. And please, would love for you to share some of your perspectives, both working in industry and for the regulators on this field of scenario analysis and how it pertains to physical risk management.
Thank you, Andrew. Thanks for inviting me to this webinar, and thanks for your general introduction. Most people called me a nerd. You actually used very wonderful words to describe my modeling background. I thought as opening remarks to help contextualize some of the introduction that you posed, because I recognize we have quite a wide audience where scenario analysis could already be used. The poll already demonstrated that, whereas others have had a little chances to work with it. So as you mentioned, scenario analysis is really relatively straightforward. You are starting your assessment on a what if scenario. So Andrew, I think you're based in the East Coast. So what if we had a Cat 4 hit the part of the coastline that you're at? This sort of scenario is not new. We use it all the time, as you mentioned it, in different contexts. I think what starts to be more interesting is that these sort of scenarios start to dominate analysis that regulators make to influence policy, engineers make to size bridges, and asset managers, such as the organization I currently work at, to shape investment portfolios. So I think that's what this discussion is relevant. I'm really looking forward to hopefully a discussion we'll have with the rest of the panelists. So if you permit me, just as an opening remark, I thought of just illustrating some cases, illustrating some of that scenario analysis to move from theory to flesh it out. So if you're so kind maybe to share some of the slides we work together, maybe I can start with some pictures, since pictures many times help us follow narratives.
Sure. Are you able to see the case study slide? Is that up on the screen?
It's not on mine, but if it's on others, then that's fine. Otherwise, I can try to share from my end.
Andrew, just try to reshare it.
That's one scenario we didn't work on. The technology doesn't work for us. We took it for granted, but there we go.
My apologies. I hope.
No, it's all good. It's all good.
No, I had taken it down when we had transferred to Georgios.
It's all good. It's all good.
Okay. Thank you. All right.
Super.
My apologies.
Here we go, Georgios. You're up. Hopefully, slides are visible.
Lovely. So maybe a very tangible case of how scenario analysis is used. This is actually not new. When I started working in the industry, so almost 20 years ago, that was the type of work engineers would have to be faced when they were sizing infrastructure. So stress testing the information they had on the hazard side to ensure that the infrastructure is appropriately strong size as it should be. Here I'm showing you some pictures on the left-hand side of a coastal flood map. It's part of the East Coast, showing you in different colors how different intensities of sea level rise and coastal surge can impact an existing urban landscape. This sort of scenario outputs can help inform decisions of where we're going to place some of our critical infrastructure. Clearly, we don't want to put something like a hospital or evacuation center anywhere close to where potentially we will be affected by an intense storm. On the right-hand side, I'm just taking a picture of a seawall. This is aspects of our coastline, but also you can imagine in terms of culverts, sizing through rivers, or even aspects that dictate how much water we might want to irrigate our fields, if you are have experience in some of those applications. Usually when we build this sort of infrastructure, it's not done for 1 or 2 years. We thankfully design it for many decades, and hence we want to stress test scenarios where the environment, the natural environment, has evolved, and those extremities is what we want to ensure that we have catered for. Have we put enough cement in? Have we put enough diameter of a pipe? Have we sized the pump accordingly? So hopefully I've given you some examples of microcosm in the planning and engineering world where scenarios have been widely used and actually for many decades now. It's nothing new. I'm going to go to the next case study and start to talk about something which is a bit more recent. And this is how stress testing is adopting scenarios to influence policymakers. Uh, Andrew, you mentioned before some regulators who have been adopting those tools. I'm guilty for working for the UK regulator and designing some of the stress tests there. Outputs of that you can see on the left-hand side of your slide. Um, what sort of questions would the regulator care to ask with scenario analysis? Clearly, they don't care about the size of a pipe or the size of flood defenses, but they do want to answer questions such as, do my insurers have sufficient capital if indeed a Hurricane 4 hits the East Coast and Andrew's home to pay back Andrew's claims? Or are we going to find situations where we're suddenly going to start eroding capital and we're going to have collapse of insurance companies, and hence Andrew is not going to be able to get his claim through? So these sort of questions, which are affecting the macro question, is what regulators care for. And they tend to be important to all of us in this room, independent of which industry we serve, because they influence policy. And as we know, policy usually has impacts for decades rather than a few months or years. Examples of that is on the right-hand side, you see an output from a different regulator, a European one, the European Central Bank, of how they look at results to influence monetary policy. So thinking aspects such as some parts of the jurisdictions that we serve will suddenly be having aspects of their GDP materially eroding. You can think of if you're in a state of Iowa, Ohio, where agriculture might be sufficiently important, that can have a detrimental impact. And if we don't have a plan and a policy to adopt to future changes, then suddenly we might have got a deterioration of income, of GDP and the like, and we want to start catering for that early on. So this sort of proactive approaches by regulators to assess impacts, whether it is on capital adequacy, on monetary policy, uses this kind of large scale scenarios, some of which Andrew touched before. Let me give you maybe another final case study of how this actually plays out on investment portfolios. I know some of you have got this sort of background. I'm just going to give you some tangible outputs of models that actually can inform of whether you want to purchase a particular issuer, Coca-Cola Inc. versus Pepsi, or Volkswagen versus Ford. How can this sort of investment decision could be impacted by scenario models? And of course, it's not just the physical models, there's also the transition models, but in all cases, it's trying to project how under a particular scenario, the value of a particular firm could be affected. And I'll give you an example. Let's assume George's Inc. is a utility and Andrew Inc. is also a utility. I do a lot of distribution of energy. Andrew produces it. If we're going to have to decarbonize, suddenly we have a policy that says we are not allowed to burn coal to make our energy. We have to use something else which is less polluting. Andrews has to spend a lot of capex to change his current factories that produce energy, and hence he's going to reduce his profits and loss. Whereas I'm distributing energy, I don't mind whether this is produced through coal or solar power. So I win, Andrew loses. So these sort of scenarios help us understand what is the potential for significant market values that we might be exposed. And as you can imagine, this can be gradual, as slowly, for instance, a car manufacturer is changing their fleet from internal combustion engine to EV engines, or very sudden if we have a particular policy change like we have in Europe, where suddenly says by 2035, no more internal combustion engines. And if Andrew's factory hadn't already taken this into consideration, we have a sudden drop in market value. On your screen, you can see outputs. I don't want to necessarily dive into too much detail, but on the left-hand side, you see how valuation can change under 3 scenarios. On the middle picture, you can start seeing how a portfolio's temperature can be aligned to whether it's close to Paris Agreement or not. And on the right-hand side, you can see how we can use scenario models to look at sectors and try to say sector A is potentially more sensitive or less sensitive than another. So what I've done over the last almost 10 minutes of my monologue, I've hopefully walked you through some examples of how climate scenarios impact already some of the work we do. I think it might be wise if I stop here, give the microphone back to Andrew for any questions he might have, and I might come back with more on this. Andrew, over to you.
Sure. Thanks so much, Georges. I did want to ask one question before we go back to the panel. Could you tell us a little bit about, in your current role with an asset manager, how in particular you're thinking about physical risk impacts on the portfolio, and what role, if any, do scenarios play in your assessment of those physical risk impacts on portfolio assets?
Thank you, Andrew, for raising. I think this kind of question, when I was dealing with it a few years back, was less relevant. Everyone was saying, oh, by 2025, by 2030, we will have dealt with this, we will have decarbonized. The crystallization of physical risk is very minor. However, I think as years evolve, you gave some examples of some acute events that have crystallized recently, and some of you might be even affected by the bushfires in Canada in terms of the air pollution you might be facing. This is becoming more and more acute. So answering now the exam question, there are two ways that we tend to look at this. There is one which is the direct impact of physical climate risk. And a very obvious example is real estate, right? So there are buildings, they are placed somewhere, they're immobile, and hence the ability of that real estate to withstand a potential change in environmental conditions, and hence its value can be impacted. Extreme cases is where you have got changes in soil conditions because of the expansion and contraction of clay under arid conditions that can start having extreme impacts, such as you write off the asset. Flooding is a case that often is quoted. We know in what happened in Texas a few years back. So you can start thinking of how valuation, both in the short term and the medium term, could be impacted by those. That's, I should say, a relatively small part of the calculation, because the other part that tends to be more dominant is the overall impact on the GDP, usually at regional level. So to give you an example, we could have situations where productivity of labor is significantly reduced because of increased average temperatures, especially where labor is done outdoors. Practical examples include mining or construction, where under some specific temperature conditions, you're not able to actually operate some of the machinery the way that you did before. So your operating hours reduce. These sort of calculations permit us to, again, assess the impact. It's fair to say, though, as you said in your introduction, that there are limitations, and still it is a fertile ground for innovation. So we're still finding new ways to quantify this appropriately. In other words, I don't trust always the numbers I produce. I have to really carefully communicate them, because I understand in many cases they might be materially underestimated. Andrew, back to you.
Thanks, Georges. Really, really helpful and insightful. So I think that really sets the stage nicely. We've gotten a sense for what scenarios are, some of their use cases, particularly for regulators and for asset managers. That really sets the scene for our next panelist, Peter Raymond. So quick introduction for Peter. Oh, and thank you, Brian, for publishing those results. Very interesting to see that we've got a good dispersion of familiarity with scenario analysis and with climate risk assessment. So that's very helpful for our context here today. So Peter Raymond is a distinguished strategist and technologist known for his expertise in geo-AI technologies. His work has culminated in Claim 8, a multiple award-winning geo-AI platform used by investors, multinationals, governments, and global leaders as it offers real-time intelligence and decision support and scenarios to effectively navigate global uncertainty, specifically concentrating on climate change, health, global risk, supply chains, and markets. His primary geo AI research has been backed by Microsoft, IBM, Autodesk, Epic, and Esri. Peter has also been named an IBM Platinum Global Entrepreneur and a GE Global Insight Leader. His pioneering approach to identifying and managing global risks is trusted by governments, the UN, corporations, NGOs, and climate summit leaders. His work has been recognized as shaping global responses to some of the world's most pressing challenges, and he has advised the Gates Foundation, the UN, WEF, and others on these questions. So Peter, you've been involved in risk, uncertainty, and scenarios for many, many years. What is your take on the utility of climate scenarios in a physical risk context, and how are you thinking about that through your work in Claimate?
Thanks, Andrew. Physical risk, we've found, has really become almost a commodity at this point. You can use established climate models. You can type in an address into a map or a tool. You understand kind of fire, flood, how many times the 1 in 100-year event, et cetera. What we find that people are really not understanding is the scenarios around those events. So it's not so much when or how the event is going to come to be, it's going to be what happens when the event happens. So when we look at what happened in New York 3 weeks ago with the smoke event, what happened? So when you add small particulate matter to a population, creates irritants, it makes your eyes water, it makes it hard to breathe. But we know what happens coming from the healthcare sector. Your ER fills up with respiratory cases. So what does that really mean? That you have a workload and you have a cost. So is the physical risk of smoke over New York City not affecting necessarily buildings per se? It could change occupancy counts. It could change how building operation is. It can control, whether labor can come and run the building. But if the hospital now is overloaded because of increased respiratory and cardio events that we see coming from the small smoke particles, where is that built in a risk mitigation plan and or any adaptation? And we kind of find this throughout any issue where we start kind of with the scenarios from just ask the question, what if? It's not so much where or when, but what if? What if our building is flooded? What if our neighborhood is flooded? What if our interstate is flooded? What if our railroad tracks are flooded? You then can ask a series of questions, usually 3 simple questions. Will the conditions improve, get worse, or stay the same? And that's what we find really helps people get into scenario analysis without getting into the mathematical modeling or the larger climactic model. So we find often in both our client work and our advisory side, what we do with a lot of large organizations, you mentioned UN and others, is helping contextualize what that means. So if we're going to have a heat dome that's starting in Texas, and remember that heat dome doesn't start in Texas, there's a border and Mexico is involved in that. Climate doesn't care much for borders. That's one thing you learn pretty quickly. The lines on the map don't matter for physics and chemistry when we're dealing with climate-related events. So you've got a heat dome that's growing. The jet stream is distorting. So the jet stream is normally this very predictable band. That jet stream starts to distort, starts to weaken. The question is, what if? What if the jet stream weakens? You can put your assets on a map, you can have a conversation with folks, or we can look at high-end stochastic modeling around that. But I think that's ultimately what we see the most of, where there's a kind of commoditized side of everyone's trying to price the risk of how much will this building be worth in 10 years if it floods. And we say, it almost doesn't matter. You have to understand the conditions that change. What if your building's fine, but your neighborhood is gone? Will the building's value change? Is it the social economic understanding of it? Is it the population health that matters? Is it the raw materials in the supply chain to allow you to put the panels and batteries that you need in a building? Those, I think, are the critical questions that we run into on the physical risk side.
Thanks, Peter. So I think you've hit on some critical points here, which are that there is a lot of exploration around what if scenarios, right? Which posit a particular event, right, or set of circumstances. Those to date have not really figured very prominently in most of the regulator-driven scenarios, NGFS, IPCC, et cetera, that by and large, with some exceptions, there are some physical event stress tests that have been done, but many of them are built around these longer term emissions pathways, right? Which use quantitative models often to predict the state of the economy many years out, but those aren't always downscaled. And I think that you've pointed out, quite helpfully, that often you're looking at assets in isolation and you're not necessarily looking at how different pieces are interlinked, right? In terms of neighborhoods, in terms of supply chains. How do you think about integrating those two pieces, or can or should they be integrated together?
Yeah, and I think they have to be. There's really no way to work in isolation in modern civilization. And what we've done is, we basically built through computation. We said, what if we could build a model of the world, digital model of the world, or a digital twin of the world, and ultimately a digital twin of civilization, which is behaviors, physics, and chemistry. How do we actually operate, and what are the rules and laws that we operate within, the physical and chemical laws that we operate in, because it really helps ground truth that. And imagine taking that globe and you spin that globe and you put your finger anywhere on that globe and being able to learn what has happened there, what's happening there, and most likely what's going to happen, or variability on what's going to happen, having a few scenarios. That can be at an asset class level, that can be at a geopolitical actor level, that can be at a supply chain level, that can be at a species level, that can be at an ocean level. And I think the piece that we saw very early on was all of this was done in silos. There was people who were looking at real estate assets. There was people who were looking at population health. There was people who were looking at wheat or other, food supply issues. There's people that were the water folks. And you see that a lot. Somebody says, I'm a water person, or I work on emissions reductions alone. And what we see is there's really no way. You could take a building as a simple kind of asset class, and a building needs water to operate. It needs electricity to operate. It needs humans to be useful for purpose in most cases. We build a building for some kind of human use. It has to exist in a system, so it can't be built too high or too low, depending on what its parameters are for the usefulness. And if you look at just a building, and take the whole globe and find one building in the whole globe, the complexity of that building is highly, highly complex. And I think what we're always interested in is, even when you zoom way in, where is the complexity? And when you zoom way out, how does the complexity still hold up, that we as humans know what to do with it? And ultimately, I think, as Georges, you mentioned, is how do you communicate this? In the end of the day, whether you compare it or you do it mathematically or you do it with the best GeoAI and geospatial tools available, if you can't communicate it, it doesn't matter. If people don't have a relationship to what that narrative is. And that's why we use narratives in scenarios. They're stories, right? Information has been conveyed through generations through stories. So when we say global flood, sea level rise will be a certain centimeter per year, it doesn't mean anything to anyone. When you say Paris 1.5 C, that doesn't really mean anything to too many people. What we try to do is contextualize that into saying the complexity really matters, but we have to simplify the interface to that complexity, such as if I'm looking at a portfolio, and my portfolio may be multi-asset classes, I may have some real estate, I may have some equities, I may have foreign currency exchanges, et cetera. You may have energy. They're highly complex portfolios because every asset in the portfolio is highly complex. In a world that's been very stable, if you think about it, the climate stabilized over a period of time, say roughly 20 to 15,000 years ago, stabilizes, and we could start doing things in place in one spot on the globe. We could grow things, and we could grow it repeatedly, meaning next year we didn't have to move. We could stay there and grow a crop. And that allowed the ability to us to develop real estate. And there are more favorable locations to stay in place and less favorable places to stay in place. Now, as the climate destabilizes, we ask kind of the core question is, if the climate stabilized to allow agriculture and real estate, the two fundamentals of our entire civilization, when the climate destabilizes, how will it, or what if the climate destabilizes to real estate and agriculture, literally how we eat and how we gain shelter, even before we go to energy or anything else, healthcare, looking at how we eat and how we live in our homes, in our buildings, et cetera. So often, even with sophisticated groups and or folks who are just coming into this practice area, ask simple questions that make it relevant to them, couple it with some of the technology, like the tool behind me is one of our tools, PlanetScan Pro, where we're monitoring the fires in Canada, the smoke, the precipitation, the particles, but we're also looking at what are the hospital loads, what is the traffic like, what happens if we had a large scale event on top of a climatic event. So the air is already bad. What happens if there was a localized fire? Does that make it better, worse, or the same for the local firefighting community? So you can really downscale these even in that complexity. You can bring it down to, does the firefighter have a better day, a worse day, or the same day if they're combating a fire in New York City in an already compromised environment? And the questions, I think, become more simple. When you do that, it doesn't eliminate complexity. It just helps you understand, I think, a starting point and how they bind together.
Thanks, Peter. Really helpful. And I really like how you juxtapose the system complexity, but simple interface, so people can really grasp the significance, right? The kind of the key takeaways and the actions. Now, Peter, if I'm correct, you said you wanted to share something on your screen. Is now a good time for that, or do you want to save it for the discussion section?
No, it's fine. We'll do it quickly now and then can come back to it. I just want to share this because I think this is relevant for at least those of us on the East Coast right now. You may be hearing the warnings about today and tomorrow on the smoke events. I put up one of our tools, if everyone can see, should be screen shared. And this is what we call PlanetScan Pro. And what we do is we scan the Earth about 100 times a day with satellite constellations, IoT sensors. So we have a very real-time ground truthing of what's happening. So when someone says, what's the temperature or what's the event, we can say, well, we'll actually tell you that. We also look at things like average household value, household income, the construction of energy, the construction of agriculture, et cetera, the very human civilization sides of the world we live in. And if you're looking right now on the map on the left, you'll see these are the current fires in Canada right now that we're dealing with from the smoke that we're seeing on the East Coast. The ones in northern Quebec, these have started fairly recently over the last 2 weeks. This is since the last large-scale East Coast smoke event. So that's growing over time. Last hotspot was detected 62 hours ago and growing. And so we're able to actually look at the fire events in real time. And having this level of data and analysis is fascinating. It's very interesting, very helpful. But the questions that we ask is, if the wind shifted the same way they did on June 7th for New York City's fires the last time, when they were small and more southerly, what happens now when those fires are still existing and you've added another 1 million acres to that fire load and the jet stream swings that smoke back down towards New York? It's not a question people think about asking because they don't really know. So we built a lot of these tools so you can very quickly ask questions. We have air quality sensors and monitors at all time. You can see the red is poor air quality, the orange is medium, and the blue is higher air quality. And we run these from a number of different indices as a whole. That changes over time. We also want to know who lives here. So what is the social economic construction of that? So the map on the right, we can look at how population is growing, where it's contracting, who's there social economically, household income. How does this affect the elderly different than young folks? Or how does it affect people who have asthma versus people who do not? What does that do for hospital loads? How does that affect energy generation with increased heat events, plus these types of things? So these tools we use as both real-time and live dashboards, and we can run analysis as needed across this. So conducting analysis, whether it's on a real estate portfolio or an asset class, or sometimes it's a factory, a supply chain, transportation, labor, et cetera. And just one of the many tools that we use to basically get to a real-time understanding. So when we ask what if, we're asking what if about something that has happened within usually the last 72 hours, if not the last 5 minutes with some of the data relevancy.
Thanks, Peter. Fascinating stuff and pretty powerful. I can really see how using tools like that can really help inform both the questions and the narratives, and of course being able to answer those questions in robust ways. So you mentioned buildings, which I think is a really good segue to our third panelist, who comes from the real estate sector. So I'm delighted to introduce Brian Geller, who is a senior sustainability manager at the Durst organization, large real estate entity based here in New York City, where he plays an integral role in the development of new projects and in the renovation and operation of existing properties. Brian develops, oversees, and implements practices in support of the Durst organization's sustainability policies. Prior to joining the Durst organization, Brian was Senior VP of Corporate Sustainability at Citigroup. Brian also acted as team lead for Sustainable Cities in the Built Environment, which included co-authoring the report New Perspectives on Climate Finance for Cities with C40 and Siemens. Prior to Citigroup, Brian founded and served as the first executive director of the Seattle 2030 District, a public-private partnership to collectively meet the Architecture 2030 challenge for planning across downtown Seattle. This model has spawned an entire network of 2030 districts across 24 North American cities with over 500 million square feet of commercial building space committed. Brian, delighted to have you. You clearly bring a wealth of experience, not only from the real estate space, but more broadly, thinking about the urban environment and public policy. So would love to hear some of your perspectives on climate scenarios and physical risk management. And happy to turn the floor over to you and share some of your slides.
Great. Thank you, Andrew. Let me just grab the screen and I'll put my slides up. And hopefully everybody can see them. I'm just trying to go into, oops, sorry, wrong slide. Go to the beginning. Okay. So thank you again, Andrew, and really appreciate the comments of our previous panelists. I think that it's all going to dovetail nicely with what I have to share here. I'm going to give a little bit of information about the Durst organization, who we are, what sort of work that we do, and how we look at climate scenario analysis. I'm going to talk about a framework we have, and then get into some specific details with one of our new development projects where we've applied this framework. So our company is a family-owned real estate company. We're now in, I know that you can see 3 generations of Dursts here. We're actually in the 4th generation. Some of these photos are a little bit old, so we really build and hold for the long term. We have what we call a generational outlook on our company and on real estate. The company was founded in 1915. We build, own, and operate, so we don't sell any of the buildings that we build. We have a long-term build and hold strategy. We've got approximately 11 million square feet of Class A commercial office and about 3,000 residential units across New York City. Some of these buildings are some of the more iconic ones in New York City, such as the Bank of America Tower on the left, One World Trade Center. We have Via 57 West in the middle. That is a Bjarke Ingels designed building on the West Side Highway that a lot of people might be familiar with. Sven, which is our newest building that just opened last year. Just to the right of that, it's a 958 unit apartment building in Long Island City. It's actually the world's largest LEED version 4 platinum building under new construction. It has a lot of amazing sustainability and resiliency features. And then the building on the right, I included, I know it's not one of the iconic ones in the New York City skyline, but 205 East 42nd Street, to the point about generational outlook, has been in our portfolio for 80 years. So I included it in here just for a little context of how far out the company looks when we are planning and thinking about how to develop and enhance our assets over time. As I mentioned, we developed a climate risk analysis framework that has 3 areas where we look at scenarios. We look at sea level rise and storm surge, increasing precipitation, and changing temperature. How can these things impact any acquisitions that we're considering, new developments that we have on the drawing board, and of course, our existing portfolio? There's a series of questions that we go through and ask. We have a screening tool that is a little bit much to show, but basically for each of these, we do an initial screen to see if there are potential issues, and if there's potential risks involved, then we do a much deeper dive into it. Just to show for an example, for sea level rise and storm surge, this is where our properties are in New York City. There's 3 slides here. I'll show you the first. The buildings in black are outside of the current 500-year floodplain, and really any near and medium term sea level rise scenarios. The ones shown in red, and here there's only one, are at that Via 57 West is actually part of it is at the edge of the 500-year floodplain. So, when we do the screen that comes up, we do want to dive more deeply into what the sea level rise and storm surge risk is for that building. Similarly, in Lower Manhattan, One World Trade Center, and then we have a group of properties on Front Street. Those are in the 100-year floodplain, and so we've been looking more closely at effects there. Sven is currently outside of any flood zones that we're aware of, and current active projects that we have in Hallett's Point, which is in Astoria along the waterfront. Those are also within the flood zone. So that 2030 Hallett's Point dot, which is a building that's under construction right now because of its location, we have looked very carefully at the flood risk for the building, and I'll be taking you through just very briefly how our scenario risk analysis was applied on that building and what some of the impacts were. So going into 2030 Hallett's Point, this is the location of the building. Again, that little dot where it says 2030 Hallett's Point, this is an overview of the site before we started construction. You can see it is right on the waterfront in Astoria, Queens. Looking at the scenarios that have been described here, these are the scenarios that we're looking at for projected sea level rise. There is a low, medium, and high estimate range. This comes from the New York City panel on climate change, the NPCC. These figures are also published in the latest Plan YC document that came out a few months ago. So this is also what the city of New York is using. So getting a little bit more granular in what this means for scenario analysis, I have a document here. I realize there's a lot of lines on the screen, but I'll walk you through what they are. The horizontal line shows some key levels on the site. We've got, what mean high water is, basically highest high tide currently at the site, what our lowest sidewalk elevation is, the lowest commercial and residential building entrances, how high Hurricane Sandy was at least the nearest location to here when that hit about 10 years ago, and then what base and design flood elevations are. So for all of our properties, we set all of these levels in a document like this, and then we project for each of the ranges that the NPCC has put out in the 2020s, 2050s, 2080s, and 2100s. Under low, medium, and high scenarios, how much higher would these things be? That's what these bars are. So for example, on the bottom for that mean high water, those colored bars that are rising up from it show under low, medium, and high emissions and risk scenarios, how high can we expect high tide to get on the site? And similarly, if there was a Hurricane Sandy-like event that hit in, let's say, 2050, and we're looking at a high emissions scenario, how high could the water potentially get at the site? That's what all of this tells us. And then it allows us, when we're planning the project, to say under these scenarios, for the relative risk of each, how do we manage that risk when we're designing the building? Because we do have some challenges. We were able to elevate the residential entry and the lobby areas up to 14 feet above sea level, which gives us a reasonable amount of protection, at least going through 2050, maybe into the 2060s or 70s under all three scenarios. But we do also have some retail spaces, and having a retail space that's on the sidewalk, elevating that space 6 or 7 feet above sidewalk level on a narrow sidewalk is pretty challenging. It's almost impossible to get people in and out of it. So this kind of lays out what those relative risks are. When we started to plan the building, you can see this is a ground floor plan of the building. I know it looks like there's a lot going on here. The main things I just wanted to call out, the areas that are shaded in white are the residential areas. They're elevated up at 14 feet. The areas in purple, light purple, are storage and retail areas. They are below that level. So doing this analysis early allows us to look at where the risk in the building is in design, consider what sort of things are in those spaces. Is there anything critical? All the technical details. Are there electrical outlets we can elevate? What are the walls made of that separate those lower from higher areas? Can they be concrete? Can they be dry flood proofed, so that we have all of this mapped out and we know ahead of time, where these issues are? Again, I know it's very small to see this, but I can tell you on the top of the drawing, which is the part of the building that faces the river, there's no doors at all. There's no openings in that side of the building, so that if there is a flood, it reduces, it reduces the risk of water infiltrating on that side of the building. Getting a little bit deeper into it, for the openings in the building, for the where DSNY picks up trash and where the retail entrances are, we do have flood barriers. We consider very early how these are designed, but in drawing them out and having our operations team involved, we can also consider, okay, how do we actually build these things? Where are they stored? When do people practice? How long will it actually take the building teams to put these together? Do they know where all the parts are? Having all of this laid out in the beginning, again, to Peter's point about scenario, it's like, okay, we have water coming up. What happens now? Are the people at the building? All of those things can be discussed and figured out. And then once the building is actually physically here, we can practice and make sure that we're prepared for a flood before it happens. The next item on the framework is about increasing precipitation. This is a particularly interesting one to me because unlike sea level rise, which at least in New York City, I know it varies a lot globally and regionally, but in New York City, it's fairly uniform. Increasing precipitation because of cloudburst events that we are having. This is a general average precipitation increase that we could be looking at over the next 75-ish years, but where it happens within the city can vary with any event. There can be, and we've already had in the last couple of years, tremendous cloud bursts in one part of the city and almost nothing somewhere else on the same day, which is not really a scenario that used to happen very much in New York City. So again, going back to this map, traditionally, we've thought of flood risk as how close are you to the rivers, but increasing precipitation can cause risks from street flooding and from water backing up through storm drains and sewers that because of the increased severities of these events was not something that was previously on real estate's radar until relatively recently. So it is something that we're looking much closer at. This is an example of that. This is a photo that often when I show people, they assume this is from Hurricane Sandy or something else. It's not. This was actually from some totally random storm that we had on April 30th of this year. The little dots you see on the lower left are because I actually clipped this image from the Instagram channel, What is New York, which if you don't follow, you should. It's very amusing, but it also has a great record for any time there are storms and events, people send it in. And so this was just some random storm where in this one area of Queens, there was a particularly strong cloudburst. This spot where we are is not particularly near the river, but it's downhill from all the surrounding areas, and the water surging into the storm drains, you could see is strong enough to blow 250-pound manhole covers off of the street. So this is something that we're looking at very closely. Fortunately, the city of New York is also studying this. They are studying where backwater valves should be applied to buildings to help reduce the risk of sewage surging into the buildings. We are also looking closely at this. We have those valves on all buildings near water. We have them on some of them that are not. We're considering adding them everywhere else, but we are, looking to see where this study goes and also looking at some other tools that the city has put together in collaboration with some local universities, which are really helpful. There is a flood map that is in beta version for street flooding, which we're also now looking at. So going back to Hallett's point, you can see that 2030 Hallett's location is shown there. You can use this tool to go to a location and show either a moderate stormwater flood or an extreme stormwater flood. This was a concern for us because, again, to Peter's point, we have a building that's on a peninsula. So even if we've protected the building and it's a residential building, if there's a severe stormwater flood event, if there's a cloud burst or a terrible rainstorm, even if we're not getting sea level rise and surge from the river, can we get to the building? According to this analysis, we might have some nuisance flooding around the building, but that key artery of Astoria Boulevard and 27th Avenue looks relatively clear. So this is, again, a new layer of analysis that we've started doing around all of our properties to see, even if we've done resilience protection at the building, are there going to be access issues if there are storms? And if they are, what sort of planning do we have to do around them? The last component of the framework is changing temperature. So this is another one where we have low, medium, and high estimates for how much hotter it's going to get in New York City. Along with this, I don't have a good graph for it because it's a little harder to put a handle on those kind of polar vortex events, which could result in extreme cold temperatures. Another thing we're looking at when we design the HVAC systems for the buildings. This creates an interesting challenge. We're not challenged from a capacity standpoint due to code and redundancy and time to heat and cool buildings and a number of other factors. There'll be no issue in terms of maximum heating and cooling capacity for any of our buildings in the foreseeable future. The challenge here is with maintenance. We have redundancy in a lot of our systems, but if let's say if we have 3 cooling towers in a building and one is down for maintenance, or if one breaks, the design right now is that even at maximum design temperature, the other 2 could serve a building. If we get into the future, that might not be the case. There may be times when all three need to run. And if we need to take one down and only two are running, what does that mean? These are the sorts of questions that these temperature increases and polar vortices are really forcing us to think about with both the new and existing portfolios. Are there any challenges from a maintenance perspective, from a flexibility of systems? Maybe if one cooling tower's down, can everything else be configured that if we have a higher water temperature coming down from the roof, it doesn't cause things to shut down. We might have a higher set point in the building for a period of time, but there's still cooling. So those are the sorts of things that we're planning for here. Excuse me. And part of that's also looking at heat island effect, where our properties, 2030 Hallett's Point, even though it's on the water, is in what's traditionally been a relatively industrial part of Queens. There's not a lot of trees in the area. So according to the city's heat mapper, which is another great interactive tool that's available, we could see temperatures 1 to 2 degrees above the city average due to that, unless we happen to be getting a very favorable wind off the water at that time. And the last thing that we're looking at, which is outside of that framework, which we're all learning right now, as Peter said, is to expect the unexpected, I feel. This is a photo from our office that I took a few weeks ago during that smog event that happened June 6th through 7th. We're very literally watching right now which way the winds are going. There was a notice that went out to, a key group that was put together after this, that we may have a smog event happening Thursday, Friday of this week. Now it looks like the winds have shifted a bit, that it may just miss us, but we don't know yet. So even as we're speaking, we're very carefully watching what's happening with that. And, there's been some measures that we've had to put in place, making sure that our staff in the lobbies have masks, because even with all the advanced filtration we have in the buildings, air still gets in when people open doors. There's still stack effect. Planning for lower occupancy at our office buildings, higher occupancy at the residential buildings. We basically had to put an internal team together that is ready to respond when unexpected events that at least for us have been outside of the scenarios that we put together happen. So that is what we're up to right now. So I'll stop there, Andrew.
Thanks so much, Brian.
Mm-hmm.
Fantastic examples, and I love how concrete you were for us on how you actually manage these physical risks with a real estate portfolio. I think I was really struck by how much new development there has been in your identification of physical risk hazards, right? And how those present risk that maybe wasn't previously appreciated, right? Until recent events. And I'm curious how you think about identification of these new hazards, and at what point does something sort of justify itself as necessitating a response, and how do you think about integrating new hazards into your plan, or reassessing old ones perhaps that are more acute than previously realized?
It's an interesting question. I think that some of it's been learning through experience. We did have properties that were impacted by Hurricane Sandy, and so we've looked more closely at that. Some of it is just monitoring more closely what's happening in New York City. We do follow very closely major infrastructure improvements, all of the flood improvements that are planned for Lower Manhattan. But we also follow even minor infrastructure improvements. We talk to our consultants, we look at what's happening. New York City has an open data portal where you can actually sort and sift any major infrastructure projects. And I say major, for New York City, maybe 10 or $20 million or larger. You can actually find those in there and get a brief blurb on them. So I have a little preset filter set where, for example, for stormwater, I can look and see what the city is doing around water and sewer infrastructure, sort it by neighborhood. One thing that we heard about recently in Queens, probably not too far from where I showed that photo, there are a large series of brick sewers that are built in a kind of circular shape that are very strong in compression. So these sewers have been there for over 100 years. They're not very thick, but they're strong enough that they've been able to withstand all of the weight that's put on them over time. But they were never designed to, and so they're designed to operate in compression. They were never designed to operate in tension, pressure from the inside. And just in the last few years, there's been a few storms where they've filled, and their water pressure in them has been so great that it's caused them to expand outward and start to break apart. The city's replacing them all now. And again, over 100 years, they've never had that happen. And now all of a sudden, the storms cloudbursts are kind of a tipping point where they can create a big problem where there was no problem. So, when we see things like that, we think, okay, we need to start paying more attention to this. This could happen anywhere in the city, including where our buildings are. So it's definitely a mixture of experience and just keeping a close eye on what's happening here.
Great. Well, thank you so much for sharing the richness of your operations and your plans. And I would love, now that we're entering the Q&A and discussion, to drill back into that in a moment. I did want to encourage our participants today to drop any questions they have into the chat. We have about 15 minutes left, and so we'll try to address those if we can. I do have first a quick round to go back to our panelists. Georges, if I might, we've heard a lot from Peter and from Brian about near-term extreme events as manifestations of the physical risk that have climate footprints. I'm curious if you could speak, whether it's in your current role in asset management with M&G, or thinking back to your time at the Bank of England. How do you see these shorter-term, more extreme event scenarios playing into assessment of physical risk exposure? And how does that sort of interplay with a lot of the emissions pathway work that you described in your presentation?
Sure. I think this is what we call acute events, so those kind of extreme short-tail events, is a perfect example of how, as a society, we have not priced in the effect of such events to our overall financial system. I think we all operate here on a first world. The type of analysis that Brian presented, for instance, in New York, will not be found in many other mega cities of the world, especially Southeast Asia, multiple of more population and impact that has. So the famous example being the 2011 floods in Thailand, and how we were not able to service microchips all around the world because the supply chain was interrupted. So this sort of assessment, I think, currently is missing, but the impacts are already felt. Think about the Suez Canal. It was not climate related, but a boat got stuck in there, and suddenly the price of timber in Canada got up, right? So we have got very early warnings of how our pockets now will be impacted. And I think Peter's work can help quantify that in a scale. It's a question of how much we are willing as a society to pay for it, in terms of prevention, in terms of resilience, and I guess many of our audience operate in that sphere. And hence the work that I do in terms of asset manager is how much can we divert capital to projects that help inform that. But I'm very happy to hear Brian and Peter's view on this, because I'm sure they're involved in similar projects.
Peter, I'd love to hear your thoughts on this. And we also have a question from the audience on the fact that 1.5 degree scenarios, which are often the baseline for physical risk, are no longer as likely or even realistic as they may have seemed in the recent past. How is that impacting the selection of scenarios that clients of Claimate need to think about? And how do you think about which questions to drill down into for the framework that you were describing, right? There's sort of an endless universe of possibilities that have physical climate risk as a driver. What is sort of the algorithm or the thinking that goes into the selection?
Yeah, I think if you take the IPCC's SSPs and RCPs, and just for familiarity, they're basically a set of model runs run on CMIP 5 and CMIP 6, which are the large ensemble models. And then they're run by multiple groups and agencies, and they create what you probably know is that curve that goes somewhere up to the right and either keeps going as the business as usual, or peaks mid-century and comes down to a temperature. Those are what I find good for about 15 to 20 years ago, when no one understood any of this. We know so much more now. We understand the currency of the data that we can pull from space or from terrestrial sensors, ground sensors. There's not a lot of guessing anymore. And what we really start with is, can we ground truth of where we are today? So if you go to NASA's planetary status indicator, today, the planetary global average over norms is 1.6 Celsius today. Not yesterday, not tomorrow, but just today. Some would say, well, didn't we break the 1.5 Paris Agreement? And you say, well, no, because the Paris Agreement is 1.5 global average over 30 years. This is just the average temperature up to today for 2023 annualized. And I watch eyes glaze over as I even talk about any of this, but it's very important to know. So what we end up doing is say, okay, let's think about it very differently. It's not even what the temperature is going to be. It's not what scenario you pick. It's what is your understanding of the world? What is your understanding of business? What can you change and what can't you change? Those are the only four things that matter. If you can't change it, you should be aware of it. And so you may be able to react to it. If you can change it, how much agency do you have and how much decision support do you need to change it, such as site selection for a location in Queens, or understanding, do we divert food as we have a geopolitical unrest in Sudan? And we're dealing with food shortages due to climate, floods, and fire. So this can be in the most remote populations or the most dense populations of the world. What we find with the large, what we call kind of the mainstream climate models are, they're very gross. They're very kind of grand in their understanding. They don't have any nuance. They don't have any of the real world ability to make decisions on. So if you look at the climate models, you'll see them, they're very smooth. They don't have much interruption in them. And one thing that we found that was fascinating with COVID, so we had some early signal detection for what would become COVID. We started running satellite scans over China and seeing emissions. If you know the Chinese manufacturing cycle and the Chinese New Year, you know that the factories shut down for a period in January and early February. It also means the coal power plants that fuel those factories with electricity shut down as well. So you typically see this emissions dip. What was fascinating with COVID is the emissions dip stayed longer because China was in lockdown. What we were absolutely fascinated by in the days and weeks and months that followed was that the temperature went up. So the scenarios even that we tend to look at from the large bodies or otherwise, they were built on a lot of assumptions. We're testing these assumptions daily with our technologies, with our ability to compute the data differently, to share observations, and understand that we're in a brand new world. We have not been here before. So as those emissions came out of the air, which, we've seen cleaner air quality in Shenzhen and Los Angeles, right? Remember those moments of COVID where people had seen a blue sky for the first time. But that brought all this little particulate matter out of the sky that blocks the sun, to make it very simple. When you don't block the sun, you heat up the planet faster. So what we did is, by reducing all the emissions, and it was a big experiment with COVID, we turned off global emissions, unlike we'd ever be able to kind of flip the switch, and the planetary temperatures increased faster. We're seeing that also over the oceans. You may have heard of the ocean temperature rising in the North Atlantic. With the desulfuring of bunker fuel, creating better emissions profiles, right? More reduced emissions of the stuff that is toxic and pollutive. What we've done, we believe, is we've heated up the oceans because we got rid of those small particulates. This is what we don't see in any of the climate models, the real world understanding of physics, chemistry, and human behavior. So and I say this carefully, and please everyone here listen to me when I say this, is it's a good place to familiar yourself with them, and you will need them to compare against others because it's become a benchmark. But for an operating or a critical portfolio manager, they're nearly useless at this point. They're so far out of date. They're extremely latent, and we have a ground truth now daily from satellites, emission counts. We can see what's really happening, and they don't match. So if you want to operate off of false information, it's not that the models are bad or wrong. It's that they're too latent and they haven't been updated or included the real world side of how civilization works, our behaviors, our geopolitics, our understanding of physics and chemistry, which is very difficult for us in the climate business because we don't want to tell people that they're wrong, but there's a reality of their purposefulness for this type of work, and we don't find that they're very useful.
Thanks, Peter. I think that is an eye-opening message, right? That there are limitations, both to the applicability and downscaling, even if one assumed they were perfect, right? To these global models, right? When you're trying to solve real-world problems in specific contexts. There's this interaction of complex factors, which you spoke to before. Brian spoke to how, some of these interactions have become much more apparent with recent events. And then there's the fact that the information is incomplete or out of date in some cases. And I think can give people a real false sense of security that these well-known globally used scenarios are the alpha and omega of scenario analysis, whereas there's really a lot of hard work that needs to go in above and beyond that. So a sobering but very important message.
And I think too that and it's often because we're bombarded with so much information. We live in an era where you can't take 5 milliseconds without a new headline, a new piece of information, a new thing to click on. And the problem is we don't have any time between those to process what that means. So we hear those headlines over and over. We hear temperatures are getting higher. We hear oceans are warming faster. We hear forests are burning faster, but we tend to normalize it. The human behaviors, the part of our work that is so fascinating, the human behavioral and the group psychology standpoint is the human mind has been built so that we normalize that, because otherwise you would be stressed out all the time. It's not a good way to live. You can't, if you come from a place where you're trying to hunt and gather and find your food and everything is alarming, it's hard to sense what's actually happening or hear the crack in the woods of an animal moving. And I think that's where we can't hear the footstep of the animal breaking a twig in the woods anymore. The noise floor is too high for us to understand any of this. The information is coming to us rapidly. It's from every place on Earth. It's not weighted for us. And when we're not able to have a framework to really understand that, it really comes down to ourselves and our groups, whether it's at our companies or our families or our communities, to say, but we know better, right? If there's a lot of smoke in the air, that can't be healthy over time. Right? Those are the questions we start to ask. Then you can get down, if you want to get into the mechanical, the engineering, the infrastructure plays, if you want to get very scientific, very deep in policy, very deep in the built environment, which is a lot of the work that we end up doing, is understanding, okay, the flood says that flood models say it's going to rise by this much, but does that include the hydrodynamic flows of the East River and Hell's Gate? That when the tide reverses and the Long Island Sound has a higher participation event, that flood water will have current. It'll also have centrifugal force. Just like you spin on a merry-go-round and you feel like you're going to be flung off, and water hits a curve, it gets higher. And Brian, when you look at that location, I know that very well from sailing through Hell's Gate, and many years I developed the 26 miles of the Brooklyn waterfront. So very intimate with that interface is, what we see in scenarios is they are so static. They take one snapshot and they consider that to be it. The complexity of the complexity is it what is so difficult. So you have to be best at what you do. You have to be extremely open and curious for this. And what we find right now is, especially in the disclosure business and kind of the overall, high level of what's the credit risk in 2045 for this bank going to be, it really has no applied application. Frankly, no one will be right. It's really just a question of how wrong will you be, plus or minus. And that's the risk that you're actually dealing with. On the physical risk standpoint, you can say, we actually know a lot more from hydrodynamic simulations, geological models, hydrology, those microburst events. We know a lot about that. The problem is there's not a lot of tools. And even if there's tools, there's not an ease of interface to those. So if you're in a C-suite, or if you're in some risk function or within a CSO position, you don't really have good tools to do this. You need to have so many skills. You need to be expert at the sciences, the maths, and then understanding the complex human behaviors of what happens when. We know that very well in the stock market. The human behaviors are basically expanded the stock market. Real estate is an expansion of human behaviors, et cetera. So how do you take that complexity and turn it into, what do I need to know now? What do I need to know in 2 to 5 years? What do I need to know in that 5 to 10 year horizon? And ultimately, do I even care and function for the 10 and 20 and 30-year-old horizons? And we often find that from some of the leadership, that they know they will have retired by those times. So they already know it's on someone else's watch. So it's just, it's not so much that they don't understand it. They know that they will not have any material responsibility for that. It'll be someone else's problem. It's a difficult part of scenarios, but it's very important when you're talking about those time scales. I think the generational side, Brian, is really interesting in that when you have that, where is that building in 60 years, not in 20?
Yeah, I mean, that's been helpful for us because there isn't really a buck stops point here. And, to your point, something we've been thinking about and we talk about a lot, we really do look at the upper end of all of the scenarios in absence of the kind of super granular information that you mentioned, because we understand that, there's the spikes and ups and downs, and then there's the trend. And we have to be prepared for those spikes. And, even this year, to your point, like, we had some real hot days in April, but it's been very mild here the last few months. And, is that because of La Nina? Is that because of all of the soot from the wildfire smoke in Canada? Maybe it's had a cooling effect here. I don't know enough to say, but I do know that, the projections are for El Nino to come back next year. And if we have a strong El Nino next year and maybe less wildfire smoke, it could be a crushingly hot summer here, and people might not expect it because it's kind of cool right now. We're having a mild summer, and people remember, people's memories aren't that long. So there are a lot of things like that that are definitely on our minds, where we're preparing for the worst, and not necessarily assuming that because things have gone well the last few years, that's just, how they're going to go, or that the projections were wrong.
And that normalization, the short memory, how many people were surprised on this call, if you were on the East Coast, to hear about smoke alerts again? I had a lot of people text me this morning like, oh, I didn't know this was still happening. Well, the fires have only grown. They haven't gone anywhere, just the wind shift. And I think that's the behavioral side of this. This is so important. Humans are actually pretty simple when it comes down to how we operate. We always say you couldn't sell Coca-Cola or Nikes to billions of people unless we were extremely the same. We think we're actually quite unique, but our behaviors are very similar, which allows you to kind of have predictions around how we will act. So what happens when you go through 2 summers of intense heat in New York City, which even 15, 20 years ago in New York, it can be stifling. What happens when this is now weeks and weeks on end? How Con Ed, the power supplier, has to deal with that, how it looks at new construction, adding demand to that for all the extra air conditioning and refrigeration you need. That's how we look at scenarios, is what is the real world consequence? So if you go to a hotter environment, you need more refrigeration. Refrigeration requires more electricity. If you just took that very simple thesis, how many spider webs would expand from the complexity of that, of hot needs refrigeration, refrigeration needs power. Spend 20 minutes and just talk about scenarios, even where you live right now or in your organization: heat, refrigeration, more power. What do those scenarios look like? And we don't see those reflected in any of the mainline climate scenarios.
Peter, Brian, Georges, I unfortunately have to bring this to an end because we're at time. I think this has been a fascinating exploration of scenarios. I think, a few quick takeaways that I had, think about the what if, right, and be prepared for the unexpected. I really liked your phrase, Brian, of being prepared for the spikes. And Peter, I think you wove in human behavior and the normalization of many new phenomena, short memories, the boiling of the frog, right? And not realizing these massive changes, even as they come on us quickly, really does challenge the intuitiveness of a lot of the response, and requires us to think more deeply about, what are these risk factors and how serious are they? So with that, I wanted to just thank you all so much for joining. This has really been a terrific session, and we'll hand the floor back to Serena to close things out.
Thanks, Andrew, and thanks all the panelists today for such a rich discussion on, such practical matters. Just from a practical standpoint, I'll keep this short since I know we're running a little bit over time. We hope you found the session today to be useful. As Andrew mentioned, the session was recorded, and so we'll likely post it to the GARI website. It might also be distributed over email. If you'd like to connect with Gary or reach out with any, follow-up questions or feedback, or connect with any of the panelists, you can reach me or Lori Collins. My email address is serena.she@lightsmithgp.com. And just a quick plug for Gary, in July, we have 2 more upcoming events. On the 11th, we're hosting a hybrid in-person remote event in Washington, D.C. on the role of public policy in adaptation and resilience finance. And then on the 25th, we will have another virtual speaker series called Finance Enabled Solutions for Equitable Disaster Resilience. So I think we should have registration links. Brian might be sharing the registration link for one of them in the chat right now, and then the one for the 11th to come over email, as well as our website. But thanks again for joining. Gary's grateful to be able to convene such a great set of panelists, and look forward to future discussions. Thanks, everyone.
Thank you all.
Thanks, everyone.
Thank you.